Okay, students, math for college. It's time to look at an introduction to linear functions. This is kind of our notes. We're going to be looking at graphing linear functions in two variables. So far, everything we've looked at has really just been just x. So when you're solving equations, we have like 2x plus 1 is equal to 8, or say, negative 3x minus 4 is less than or equal to 6. So to the equations and inequalities, you can see you just have x. But what if we have x and y? There's a few ways to graph. And, we're going to talk about slope-intercept form and things like that. But for right now, one way you can make a graph is by using a table of values. And sometimes a great way by making a table of values is plug in, say, 0. And if you let x be 0, we have y is then equal to negative 2 times 0 plus 1. And you get 1. So that means that 0, 1. So because we have two variables, we now have two axes, an x-axis and a y-axis. And we can place that coordinate there. I'll make another one. I'll plug in 1. Negative 2 times 1 plus 1, that'll be negative 2 plus 1 is negative 1. Plug in 2, and we get negative 2 times 2 is negative 4. And negative 4 plus 1 is negative 3. And so over 1, down 1, over 2, down 3, you can notice that this is your shape. So this is your line, okay? All right, as you look at your next one, this one is different because it has a fraction. And if you plug in 0, it's fine because 1/3 times 0 minus 4, you can see 1/3 times 0 is 0. And 0 minus 4 is negative 4. Okay? But if you plug in 1, 1/3 times 1, that doesn't work out very well because 1/3 times 1 is 1/3. It's a fraction. So sometimes it's really good to plug in a number that's divisible by 3. For example, if you try 3, 1/3 of 3. So 1/3 of 3 is 1, minus 4 is negative 3. Try another number that's divisible by 3. Say 6. 1/3 of 6 minus 4. Well, 1/3 of 6 is 2, minus 4 is negative 2. So you can see that if you have a fraction, if you plug in numbers that are divisible by that fraction, then it works out much better as you try to produce points. So making a table of values is one way to be able to graph a line. Here's another way to graph a line, is to produce X and Y-intercepts. Now, if you think about an X-intercept, that's where the graph crosses the X-axis. And when a graph crosses the X-axis, we know that the Y value is 0. And when a graph crosses the Y-axis, we know that the X value is 0. So if you want to be able to graph a line, one great way to do it is to be able to plug in 0 for Y and then find the X-intercept. Notice what happens. You get 2x plus 0 equals 4, or 2x equals 4. When you solve that, you get x is equal to 2, and so 2 is the X-intercept. Now, if I switch it up and I plug in 0 for x, I'll find the Y-intercept. Plug in 0 for x, you get 0 plus y is 4, or y is equal to 4. So we plug in 4, and now we can graph our line. The next one, we'll find the X-intercept by plugging in 0 for y. And notice how it just goes away. You get negative 3x is negative, not 36. Negative 3x is negative 6. We divide by negative 3, and x is 2. So it crosses at 2. Then we'll find the Y-intercept. We'll plug in 0 for x. If x is 0, that goes away. I get 2y is -6. So y is -3. We plot -3, and now we can graph our line. So those are two ways, and I know that everybody's thinking about slope-intercept form right now. That's what you're used to, and we're going to do that. But making a table of values, looking at x and y-intercepts, these are things that you should be able to do as well as you consider wanting to enter into a college math class. Those are skills we should have. Here's another thing you can do. You can use point and a slope. It says graph the line has the following properties. A slope of -2/3. Slope is your rise over your run, and we always run to the right. Okay? So it passes through the point -3, 4. So I go back 3 and up 4. And it says it has a slope of -2/3. That means I drop 2 and I run 3. I drop 2 and I run 3. I drop 2 and I run 3. Your next one says you have a slope of 4, or 4 over 1, and it passes through 2, -5. Over 2 and down 5, that's my point, and a slope of 4 over 1. So I go up 4 and over 1. Up 4, over 1. And you can see the line that you get there. You are most familiar with slope-intercept form, which is y equals mx plus b. M is what we call your slope, and B is what we call your y-intercept. If we can put this equation into slope-intercept form, we can graph it quite easily. If we subtract the 3x from both sides, we get y is equal to -3x plus 1. Looks like the slope is -3 over 1. The y-intercept is 1. The directions say to identify that and then graph it. To graph it, I plot 1 on the y-axis. The slope is -3 over 1, so I drop 3, and I run 1. Drop 3, run 1. There's my line. -2x minus y is equal to 3. I'm going to add 2x to both sides. When I do, I get -y is equal to 2x plus 3. Divide by -1, and I get y is -2x minus 3. So the slope is -2 over 1, and the y-intercept is -3. I plot -3 on the y-axis. I go down 2 and over 1, down 2 and over 1, and that will be able to create my line there. (4x plus 3y is -6. Subtract the 4x. And 3y is -4x minus 6. Divide by 3. Y is -4/3 x minus 2. So the slope is -4/3, and the y-intercept is -2. I plot -2. Slope is -4/3, so down 4, 1, 2, 3, 4, and over 3, 1, 2, 3. There's my line. And for the last one, -2x minus 5y is equal to 5. Add the 2x to both sides. And I get -5y is equal to -2x plus 5. Divide both sides by -5. Well, I'm sorry, it was a positive 2x. Sorry about that. Y is -2/5 x minus 1. So the slope is -2/5, and the y-intercept is -1. Plot -1, and slope is -2/5, so down 2 and run a 5. Draw my line. So as we review, Slope-intercept form is one great way to graph. Given slope and a point, another way to graph. Making a table of values, another way to graph. And determining X and Y-intercepts, another way to graph. As you look at your worksheet, please pay attention to the directions, as you will be asked to do these different variety of things on the test. So be ready to ask questions. Good luck. Please reach out to me if you need any help.